Space shuttles are one of the biggest achievements in human history, but there's a lot of things that happens in the background. How does a space shuttle take off? To begin the takeoff, the space shuttle uses four things to lift off the platform up to orbit: two solid rocket boosters, three main engines of the orbiter, the external fuel tank, and the orbital maneuvering system engines on the orbiter. The solid rocket boosters provide most of the main force or thrust that is needed to lift the shuttle off the launch pad. The main engines provide the remainder of the thrust to lift the shuttle into orbit. The external fuel tank is where the fuel for the main engines is located. It holds about 1.6 million pounds of propellant. The OMS engines place the shuttle in final orbit, change the shuttle's position, and slow it down for reentry. Now, what happens to a space shuttle while in orbit? Once in orbit, the crew will open the cargo bay doors to cool the orbiter so that it can work correctly. The shuttle needs to have life support, including an atmosphere similar to Earth, breathed out CO2 and contaminating gases removed, and a normal humid environment. The shuttle will need to have water on board so that the crew can drink and stay hydrated. Since outer space has an extremely cold climate, the shuttle will need to be able to control the temperature so that the crew can survive in space. Now, how does the space shuttle land back on Earth? When a space shuttle is coming back down to the surface to land, there are special things that occur. One of the things that occurs is the engines and air resistance slow the shuttle down so that it isn't going at an incredible speed towards the Earth. NASA says that it is kind of like an airplane coming back down to land. The shuttle will have wheels that drop down from underneath the orbiter, and it will slowly roll to a stop on a runway somewhere after deploying a parachute. Now, how does a space shuttle re enter the Earth's atmosphere when coming back? That's the tricky part of the whole process. As the shuttle is coming back down, gravity is pulling it back to the surface with increasing speed. One force that the shuttle will experience that dramatically increases the closer it gets to the surface is drag. Since the Earth has air particles, the shuttle will rub against those on its way back down, creating friction. The friction will cause the shuttle to experience air resistance, which will end up slowing it down for a safe landing speed. Now, how do you build a space shuttle so that it can resist the solar flares from the sun? The engineers of space shuttles knew that the shuttle will experience extreme conditions while in space. So they built a thermal and structural model of the space shuttle to test it in a chamber that they built. In the chamber, they applied a high amount of heat and coldness to see how it affected the spacecraft. Since the space shuttle was built knowing the extreme temperatures in space, it was able to hold up against the solar flares from the sun. Why don't we use the space shuttle anymore? Well, first, we don't use it because NASA realized that it was way too expensive to build. They were having to keep up with the 20-plus-year-old orbiters, which was getting more costly each time they were used. Money wasn't the only reason, though, that NASA stopped using space shuttles. Another reason is that there aren't enough trained and experienced people in spaceflight operations. So they aren't able to keep up with it anymore, so they canceled the space shuttle missions. And here's my works cited page. Thank you.